Good morning, Algebra II students, and welcome to 14.3. We've been working on conic sections this chapter, and we're going to cover another one today. Getting close to the end of the year and what we want to accomplish this year. But this time, what we're going to work on is we're going to work on the ellipse. It says here that the ellipse is the locus of points in the plane such as the sum of its points is the distance from two fixed points is constant. And so let me kind of explain this to you a little bit. Conical sections, if we have a cone, we can slice that a number of ways. And right now we have three different ways that we slice it. One is parallel to the nape or the top or the bottom, and that would get you a circle. Let me redo that. That's not very circular. Okay. That's the first one we talked about, which has a uniform radius. And the next type would be as if we sliced it not parallel, not perpendicular to the nape. And then we would have a parabola. And the third would be as if we sliced it all the way through like that, and we would have the ellipse. Now, with the ellipse, there are 2 points, like yesterday when we were working on the parabola, we talked about its focus and its directrix. When we talked about the circle, it had a center. An ellipse has 2 focal points. Now, what happens with an ellipse is, you know how like if you took a circle and you put a stake, if you took a stake, put it in the ground, tied a string to it, and you just made a marker all the way around, you would have a perfect circle. If you had one string connected to 2 stakes, it would stay constant. That string would stay constant throughout an ellipse. So like let's say that line that I have here, this angle that I have here is maybe 7 units. If I did the same thing over here, that would also be 7 units, and so it stays consistent throughout. That line is the distance of that line is going to be found out throughout. Okay, and so how we're going to find those focal points is by finding the distance A. Now, something strange, and that you're not going to be, remember I said you want a note card because there's all these things that really trip you up. We have the equation of the ellipse. You'll see H and K are both negative, so that means they both lie to you. But also we're going to see that in order to calculate the value of C, which is going to allow us to find the focal points, we have A squared plus A squared equals B squared plus C squared. See, I almost said it wrong. We're so used to Pythagorean's theorem, A squared plus B squared equals C squared, that this actually looks a little confusing to us. A squared equals B squared plus C squared. But hopefully as we describe this, it will begin to make sense. So here you could see I have clearly labeled where the focal points are. And the focus is, and I'm going to keep my highlighter out here, and I'm going to kind of show you the distance C, the focus. What C is important is that it tells us the distance from the center, the HK value, to the focal points of the ellipse. That's what C does. And so you can see there that A and B, well, at least A, will be guaranteed to be longer because A is the distance from here out to here. That's A. So you can see that C is guaranteed to be shorter than A. So as you're looking at this, it's important that you know that A squared can be either under X or Y. Like if I go back to the equation, you'll see here in this example, A, let me get out a laser pointer. A is under X and Y, and B is under Y. Now these two could switch. A and B can switch. a squared will always be the larger of the two. So if we have a squared is 9 and b squared is 16, we'd say that this is actually a squared, called the major axis. So a is the major axis and b is the minor axis. Hopefully that'll begin to make sense as we try some. So here's one that we look at, and as we begin, we notice that there's no h or no k. I can even rewrite this as x plus 0 squared over a squared plus y plus 0 squared over b squared equals 1. Now, an ellipse will always equal 1. Like, this is a must for an ellipse. They will always, always, always equal 1. So when later on in the chapter you're going to be asked to decide, is this an ellipse, is this a circle, or whatever, in graphing form, an ellipse always has to equal 1. So the center is at 0, 0. Okay. Now my major, I don't know why I was talking too much. This is 32, and this is 48. Now this actually ends up being a squared, and this actually ends up being b squared, because this is the major axis, and this was the minor axis. So as we do that, what I'd like to do is I'd like to find a and b. So again, if we're working on the major axis first, a squared equals 48. So a equals the square root of 48. Technically, and this works out really, really nice for us, it's plus or minus the square root of 48. Now, even without my calculator, I know that that's going to be approximately positive or negative, just a little bit less than 7. So like 6 point, that's an estimation. I'm actually got my calculator out, and I'm going to try and figure that out as exact as I can. Well, it's 6.928. So actually, I'm just going to erase that little line above the 9. And so 6.9. So that, my guess was pretty good. So that means I'd go up about 6.9 in the positive direction. And I'm going to go down 6.9. And the reason I went up and down is look at where the position is. It's underneath y. So that means that this a squared is going to be vertical because it's under y. Does that make sense? So if the 48 was under the x, we'd go horizontal. So now if we talk about the minor axis. The minor axis, let me get a different color out here to try and help us understand this, is b squared equals 32. So b equals plus or minus the square root of 32. Oops, I'm so used to writing 36, I just did that by... So I think it's going to be approximately, just an estimation before I even get started, I think it's going to be about 5.5. Well, let's give it a try on my calculator. I'm not as confident as I was about the last one. So square root of 32 equals 5.6. Oops. 5.6. So still about 5.5. So that means I'm going to go 5.5 to the left, and I'm going to go 5.5 to the right. And now what I can do is I can connect the dots in kind of a circular elliptical fashion. This looks pretty close to a circle because 32 and 48 are pretty close numbers, but it's actually not circular. It's actually elliptical. So there's my ellipse. Now the tricky thing here is calculating the coordinates of the foci. So remember, the equation is a squared equals b squared plus c squared. We'd like to find c. So a squared, again, is the major axis. Again, here written a squared, so 48. That's always got to be the biggest number. And b squared is 32, and so that'll allow us to find c squared. So this comes out kind of neat because it's 16 equals c squared. So c would equal plus or minus the square root of 16. So c equals plus or minus 4. So if I were to go over to my graph, I'm going to have the foci at up 4 from the center and down 4 from the center. So the equations of my foci are at 0, positive 4, and 0, negative 4. Okay, that's where my foci are. All right, hopefully that began to help you understand a little bit more. Don't worry, I got a number of them that we're going to do. This one's quite a bit trickier because remember what I said on the last slide? I said your ellipse has to equal 1. In this particular case, the ellipse does not equal 1, so we need it to equal 1. So I'm going to divide everything by 576, because if I take this and I divide by 576, divide by 576, and divide by 576, what happens is this value right here becomes equal to 1. Now, I'm guessing, and this is what's probably going to happen in your book, that if we were to reduce all of these, they're going to come out evenly. So if I take 36 and 576, 36 goes into 576 16 times. And well, that means for the other one, x squared reduces to 36. So that gives me a major axis and a minor axis. If I do 576, if divide by 576 from all sides, then I get my major axis and my minor axis. Let me show you just once again how I'm doing this. This reduces. I can take 576 and divide by 36, and I'll get 16. And I take 576, and 16 goes into that 36 times, just like that. So that's how I came up with this value here. And so that's going to allow me to find my center, just like on the last slide. It's 0, 0. And then if I were to take, and now we've got to decide what looking at the graphing form right here, I got to decide which one's my major and which one's my minor. The a squared value, or the major, this time is under the x because it's greater than the y squared value. So b squared is the minor, and that's under y. Okay, so I got a squared and b squared. So if I were to look at the major axis first, the major axis, a squared equals 36. So a equals plus or minus 6, because the square root of 36 is 6. So that means in the x direction, I go out 6, and I go out 6. This is my major axis. Okay. Now in my minor axis, it comes out cute too. B squared is equal to 16. So B equals plus or minus 4. So I go to the center, and I go up 4, and I go down 4. I think this one's going to be a little bit easier for us to see how it's elliptical. So now I'm going to connect my dots in an elliptical fashion in order to graph my ellipse. That one comes out nice on this little graph. All right, there we go. So the last thing, we already determined that the center is at 0, 0, because that's my HK value. So the last thing I need to do is I need to find out where my foci are, and I need to find the coordinates of my foci. So what we're going to do first is we're going to start with the equation that we had on the first slide. A squared equals b squared plus c squared. Again, this is backwards from what you're used to. You got to be very, very careful. Again, you really want to put together a note card where you're going to have these different equations on them so that you can refer back to it, especially come test time and stuff. I know it's probably going to be open book test, but still, this is going to be really handy for you to be able to solve these. So our a squared value is 36, and our b squared value is 16. So if I take 36 and subtract 16, I'm going to get 20 equals c squared. So c equals plus or minus the square root of 20, which, if we were to rationalize this is 4 times 5, so it's actually 2 root 5 plus or minus equals c squared. So you go, okay, Mr. Wilson, but what, 2 root 5, that doesn't tell me much. I want to know an approximation of it, so I'm going to get out my handy dandy calculator, and I'm going to try to find the approximation of 2 root 5, which is approximately 4.47, or 4.5 is what c equals. So I'm going to place my foci I go from the center. I'm going to kind of spell this out. I go 1, 2, 3, 4.5 from the center, and 4.5 the other direction. 4.5 the other direction in order to get my foci. This is one of the foci, and this is one of the foci. So if you want to find the coordinates of the foci, I always say, here's how you do the coordinates of the foci. Is I put together a relation like this, and I always put like the center there, like the comma in between the x and y value. And then what I always do is I take the center and I put 0, 0, just like that. And I say, okay, which one is this traveling on, x or y? You can see right here, it's traveling on x. So I'm going to go, this is the x part, this is the y part. I'm going to leave the y part alone. So like in my final answer, I'll just have this be like 0. Then over here, I'm going to add or subtract the c value. And we have the c value right here as plus or minus 2 root 5. So then if I simplify that, it'd be the foci's coordinates are plus or minus 2 root 5. Okay, foci. Foci. All right. Hopefully you're beginning to understand this. We'll keep going, and hopefully you're getting it. If you got any questions, please take time to contact me. Give me a call, send me an email, let me know where you're going. And actually, it's really hard to answer a question over email. Easiest way is to call me. All right. Here, again, same type of problem. This time, we have to set it equal to 1. Remember, because graphing form, if go way back to the beginning, the graphing form equals 1, just like that. This does not equal 1. Starts here. This is in general form, not graphing form. So I want to put this in graphing form. So how I do that is I take the final value here on the other side, and I'm going to divide that from everything. So I'm going to divide 32 here, I'm going to divide 32 here, and I'm going to divide 32 here. Okay? So it equals 1, and then I can reduce these, if I can. Hopefully I can. This goes in 16 times, which is kind of nice. So we get y squared over 16. So far, I'm being really nice to you. Everything on the top is just x and y just kind of come out neatly. And 16 goes into 32 2 times. So x squared over 2. Everything's come out evenly so far. So I like that. So the first thing I notice is the center is at 0, 0. So I can start there. It does move around. You see next one, it's going to move around. I just wanted to check. I knew probably had to move around. So now we're going to start, and we're going to say which one's the major and which one's the minor. This time, a squared major is under y. And b squared minor is under x. Okay? So if we started with the major, which is vertical, it's going to travel vertically because it's under y. A squared equals 16. Hopefully you get that a is going to equal positive or negative 4. So that means I can go up 4 from 0, 0, and I can go down 4 from 0, 0. Now we can kind of work on the minor. The minor is going to travel horizontally. The reason is that it's under x, so that's why it's going to travel horizontally. And so b squared equals 2. This is a good time to pay attention here, because that does not mean that b equals 2. That means b equals the square root of 2, plus or minus the square root of 2. Don't get caught on that. I've had so many students on tests, they make that mistake. So b equals approximately plus or minus 1.414. So a 1.5. So that means horizontally, I'm going to move out 1.5. And I'm going to move out 1.5. Now, remember, the foci are going to travel on your major axis. So your foci this time are going to go up and down. So our foci are going to, get out the laser pointer here. The foci are going to lie someplace on this line right here on the major axis. I don't know where that is. I gotta solve it by the equation a squared equals, oh my, be careful, because actually, as we progress further on, we're going to have to use Pythagorean's theorem again in a later chapter. So we need to make sure that with an ellipse, to find the foci, because the foci are not the longest point, it's still based on, and let me kind of show how that would work, is that we always have the foci. Well, never mind. It ends up forming a right triangle. I don't want to bore you with y. So, but a squared, in this case, is 16. B squared is 2. Now, b squared is 2. You can see right there. B squared is 2. It's not 1.414. Equals c squared. So, c squared equals 14. So, c equals plus or minus the square root of 14, which is actually very close. It's going to be very close to our major axis points. So if we go square root of 14 and we try to find out what that is, hit the button wrong. Square root of 14. Hit the button wrong twice. Excuse me. Okay, 3.7. So C equals plus or minus 3.7 approximately. So it's there's a foci there, and a foci way down here, foci. All right. The purple dots there are the major axis, except for the center I've also got as purple, and the green dots are the minor axis. As we continue on, if we want to find the coordinates of the foci, again, I'm going to show you how this is done. This might seem a little redundant right now, but trust me, doing this will make sense a little bit later on. Put the comma in the middle, because this is going to be a set of coordinates. Take the center, 0, 0. And then what is this traveling on? You can see the foci, again, are right here. They travel along this way, so that means they travel with the y. They don't change any x, they just change vertically. So that's going to cause this part to stay the same, because they don't move horizontally. But then you could say plus or minus the square root of 14 to be the most exact answer. Then if you wanted to simplify that, you could say the foci are at 0 plus or minus the square root of 14. And you could, if you wanted to, you could say 0 plus or minus the square root of 14. Wouldn't hurt my feelings at all. All right, let's move forward. This one's a little bit different, because you can see the center isn't at 0, 0. Where is the center? Hopefully you've gotten to this point in this chapter where you realize that the HK value is going to be 1, -2. In an ellipse, both H and K, Y. Again, parabola H lies, K tells the truth. Circle, they both lie. So it changes up. So a note card is going to be very, 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 very helpful for you. Even if it's an open book test, having it right there on one note card is going to save you a ton of time. Put together a note card. Do that now before it's test day, okay? So my center again is at 1, -2, right there. That's the center. And now I'm going to find my major axis and minor axis. This is the major. It's underneath y, so that's a squared because it's bigger. And this is the minor. That's b squared, and it's under the x. So let's start with the major, which is a squared equals 9, and it's vertical because it's under y. So a equals plus or minus 3. So that means I can go from my center, not from the origin, 0, 0, from the center of the ellipse. I can go up 1, 2, 3. And I'm going to go down 1, 2, 3. This is my major vertices points. Don't go from the center because then it'll look all funny. And don't go from the origin. Don't go from 0, 0. Then my minor is going to be a horizontal change. Let me get green out because keep doing the same color, you begin to get lost, especially when you come back to look at your notes. It's horizontal, and it's b squared. And b squared is 7, so b equals plus or minus the square root of 7. Can't rationalize that, so I'm going to try and find an approximate value. I'm going to say the square root of 7 is approximately 2.6. Equals plus or minus 2.6. That means that from the center, I'm going to go over 1, 2, and a little bit more. And then from the center, I'm going to go over 1, 2, and a little bit more. So now I'm going to take and I'm going to connect the dots. Just like that. And I have the graph of an ellipse. Looks pretty circular, doesn't it? But it's actually not. It'd have to go out a little bit further. It's kind of a smushed circle. So now I got to find the foci. Foci are found by a squared equals b squared plus c squared. So if a squared is 9 and b squared is 7, that would make c squared equaling 2. So c equals plus or minus the square root of 2, which we've already today determined square root of 2 is plus or minus 1.414. Okay? So that means I'm going to go up about 1.5. And let me get a different color to do that. Blue, 1.5. We got a foci, and 1.5 down, we get a foci. So remember, now this is where the exercise I had you doing earlier to find the coordinates of the foci is going to become. So your foci, what you want to do is you want to set up your relation set of ordered pairs. Then you want to start with the center, 1, -2. Then the next question you can ask is the major axis. Is that a vertical change or a horizontal change? Is it under y or is it under x? You'll see right here, under y. So that means our foci change comes on the y part. So I'm going to take and I'm going to say it's -2 plus or minus, and right here, the c change is going to be square root of 2. So if I wanted to simplify that answer, just kind of make it look a little bit neater, it's going to be 1, comma, -2 plus or minus the square root of 2 are the coordinates of those foci. And that corresponds, actually, it almost ended up being, that line almost ended up being a perfect arrow to what I was looking for. But that point corresponds to, point corresponds to right there and right there. Those are the coordinates of your foci. All right, let's keep moving on. Is this the last? No, it's got two more, okay? So, here, let's start with what we know. We know that the foci are at -4 and +4. And we know the major axis points are at -6 and +6. So where's the center of this thing going to be? I believe the center is going to be right there at 0, 0. Because that's right smack in the middle. Now, if it was moved around a little bit, you still have to see there's 4 units this way and 4 units that way. You could use that same thing if the center wasn't at 0, 0. Okay, but that's where the center is. So now I need to find the equation of the line. I need to graph this, and I need to find the minor axis. I believe I'm going to start by finding the minor axis. Well, don't we know that it's like a squared equals b squared plus c squared? If the major axis is 6, wouldn't that make a equals 6? So a squared would equal 36. And b, or no, this is c. c equals 4, because it's 4 units from the center and 4 units from the center. So c squared equals 16. So I can put that over here, 16. So now, that'll allow me to find b squared. If I subtract 16 from both sides, I'll get b squared equals 20. I don't really need it. Well, no, I do. b equals the square root of 20, which I believe we did that already. I just don't have that memorized like I did the other one. 4.47. I should get it memorized. b equals plus or minus 4.47. 47. So about 4.5. So that means I'm going to go up 4.5, down 4.5. Those are my minor axis points. Now I could connect the dots. Major axis to minor axis. Don't go to the foci. Oh, wait. Went to the wrong point. There we go. Don't be afraid to, like, if you do something wrong, don't be afraid to erase and fix it. Okay, so these are my foci. Okay, now we gotta write the equation in the graph. Well, our center is 0, 0, so it's gonna be x squared and y squared, and it needs to equal 1. What's the major axis? The a squared value. Sorry, a squared's under x too. So what's a squared? 36. And we determined what b squared was. It was 20. So that's the equation of the line. All right, let's do another one. Here we go. See, this one I've just got the graph, and I need to find out all the information about it. Well, if we look at it, here's the major axis point, I believe, and here's the minor axis points. So couldn't we kind of like find the middle, like it goes 2 units this way and 2 units that way, and then in the major goes 3 units this way and 3 units that way. So that I believe that would make this the major, and that would make this the minor, and that would put the center right there. So that means the center is at 0, -1, 0. -1, 0 is where my center is. So when I come up to my equation, eventually I'm going to say x plus 1 all squared and y squared, or y plus 0. It doesn't really make a difference, and it's going to equal 1. So now I could also tell, I know how far it is to the major axis. with the major axis, a equals plus or minus 3, right? Because I counted 1, 2, 3 on the major axis. So a squared equals 9. And it's traveling vertically, so I put it under y because it's vertical. So it goes under y. And b, we already counted, equals plus or minus 2. There's those green lines over there. I went over here and went 1, 2. So that's how I found that. So b squared equals 4. And so it's horizontal, which means it's under x. That's going to be 4. Not because it's not b, it's b squared. All right. So then I also have to find the focal points. So how I find the focal points is a squared. And I'm not saying that every question you have that'll do these are going to ask for all these parts. I just want to cover everything. So the major axis was 9. The minor axis was 4. And that allowed us to find c squared. So 5 equals c squared. So that's at the square root of 5, which is just a little bit more than 2. So c equals the square root of 5, which is just a little bit more than 2. So I'm going to put them there and there. And I'm going to say, now here's where it comes into play again. We start with the center. -1, 0. Now what's it travel on? The x-axis or the y-axis? What's the major axis? You're right, y. That means we're going to do plus or minus the square root of 5. So then if I wanted to reduce the focal points, it would be at -1 plus or minus the square root of 5. Okay, there they go. All right, here. Whoa, look at the homework you were going to have. I don't know if you like the fact that we have COVID year this year, whatever. Let's do number 1 and 2. I agree with that. 5 and 9. I agree with that. Let's say 14 and 15 to go. All right. 19. We already did one like 19. 22. I like 22. But I don't know that we need to do 23 or 24. Well, no, do 22 and 23. But don't do 24. And 27, 28, and 31. We got to do one of those. Let's do it 27. Okay? 27. So we got 1 to 2. That's 2, 5, 6, 7, 8, 9. That's 7, 8, 9, 10. So 10 questions. 1, 2, 5, 6, 7, 8, 9, 22, 23, and 27. Let's see.